Hi, and welcome to day 8 of Radicals, the Radicals unit. Today we are talking about the absolute value equations and inequalities. We're trying something a little different today. I already have the notes written, and I scanned them in this way instead of trying to do all this writing because there is a lot of writing on this one. Hopefully it will go a little quicker for you, and you'll be able to read my writing better than my chicken scratch when I use the actual computer. But just a reminder, the absolute value, absolute value is equal to the distance away from 0, whether it be from the right or the left. So that means the absolute value of 6 is 6, the absolute value of negative 6 is 6. And if the absolute value of x is equal to 3, then x would have to be 3 or negative 3, because both of those would be 3 units away from 0. So when we're solving absolute value equations, we need to solve two equations. Okay? And what we do is initially we just drop the absolute value signs, so we get x minus 7 equals 5. And we solve that little equation. I would add 7 to both sides, and when I did that, I'd get x is 12. Then I need to solve for the negative value, because I have values to the right of 0 that would work for this, and values to the left of 0 that would work for this. And it's not necessarily 0 itself, but the 0 of the problem. So what I do is I would say x minus 7, which is inside my absolute values, equals a negative 5. Notice here I just changed the sign to its opposite. So I'm going to add 7 to both sides, and when I do that, I will have x is equal to 2. Then, of course, I need to check to make sure that everything works out. If I put 12 in for x, I'd get 12 minus 7 is equal to 5. So the absolute value of 5 is 5. And then I have to try 2, and the absolute value of 2 minus 7 is negative 5, and the absolute value of negative 5 is 5, so that checks out. My solution set is some people call the sexy brackets, or just the funny brackets here, 2 and 12. So let's try another problem. All right, for number 2, the first thing we need to do is get the absolute value alone. Okay, in order to get the absolute value alone, in this problem I need to subtract 3 from both sides. So the absolute value of x equals 2x minus 3. So initially I just dropped the absolute value, and I would get x equals 2x minus 3. Subtract 2x from both sides, so I have negative x equals negative 3, divide by negative 1, so x equals 3. Or I have to solve this by changing the signs. Okay, I'm going to negate the right-hand side. Well, I need to negate the right-hand side, so that means I need to negate everything there. So I'll just put negative 1 times 2x minus 3. So I would get x equals negative 2x plus 3. And then I just solve it like I would any other equation. Add 2x to both sides, so I get 3x equals 3. Divide by 3, so I get x equals 1. Then I need to do my checks. So I have the absolute value of 3 plus 3 equals 2 times 3. Notice I went back to my original problem when I did the check. So I would get 3 plus 3 equals 6, and 3 plus 3 is 6. If I substitute 1 in, I would get the absolute value of 1 equals 3 plus 2 times 1. Well, 1 plus 3 is 4, which is not equal to 2. Therefore, I would reject the x equals 1, and my solution set is just 3. These can be a little bit tricky, but as long as you remember to get the absolute value by itself and to solve for the positive and negative value, we just need to be careful here of this negative 1. Right, if you have a binomial, you have to make sure that you distribute that. Okay? So, moving on. Alright, this is the back side of the notes. I have put some information up here along the top to kind of help you out. If you have a greater than sign, or greater than or equal to, remember that's greater than or equal to, this is greater than, you would have open circles for greater than and closed circles for greater than or equal to. Greater than means the word or. We can say or. It's this or that happens. And when we do that, we shade away all the time. When I have less than or less than or equal to, we have open and closed again. Less than means and. Okay, it has to be both conditions at the same time. So we would shade between. This is always the case for every less than problem or every greater than problem. And remember, when you have more to the sign, you have more to the circle. And we're going to play this game again tonight. Alright, so I'm going to start off easy with the inequalities. If I have the absolute value of z is greater than 2, whenever I have the greater than symbol, I need to flip the sign and negate to find my second inequality, just like we did with solving the equations. Okay, so the absolute value of z is greater than 2. Or then I would just say I have z equals to or z is less than negative 2. I flip the sign and I negate it. So therefore my solution set would be z such that z is less than negative 2 or z is greater than 2. Well, since I just have greater than, I have open circles, notice right here, open circles, and I'm shading away. If you look at how I write them, z is less than negative 2 or z is greater than 2, the way the inequality is pointing is the way I'm shading in some of these problems, if you follow and do it the way I do it. For number 2, the absolute value of z is less than 2. We write this as what we call a compound inequality. What a compound inequality is we have two inequality signs in one sentence. So for example, excuse me, I'm going to negate my negative 2, just like I did over number 1. I'd say negative 2 less than z less than 2. What this is really saying is z is less than 2 and z is greater than negative 2, which means it's in between both negative 2 and 2. Okay, so that's everything in here. My solution set then is z such that negative 2 is less than z, which is less than 2. Notice my solution set and my answer are essentially the same thing. Alright, moving on to number 3, I can compare all of my problems to either number 1 or number 2. Number 3 is the absolute value of x is less than or equal to 5. Number 3 has the less than sign, or less than or equal to, therefore it's the same as number 2. So I'm going to go back and follow my rules for number 2. What this means is I can write a compound inequality. When I write my compound inequality, it becomes negative 5 less than or equal to x less than or equal to 5. Because it is less than or equal to, my circles are closed. And because it's a compound inequality, I shade in between. Number 4 is the absolute value of y is greater than or equal to 6. That one is the same as number 1. So this type of problem, I need to do two inequalities. One for its 6 positive value, and then one for negative 6, or my negative value. So I have y is greater than or equal to 6, or y is less than or equal to negative 6. Well, if I put this on my number line, y is greater than 6 goes this way, y is less than negative 6 goes that way, and again, notice my inequalities are pointing and shading the same way as my symbols up here. Okay, number 5 is a little bit more complex because I have more than just one term inside my absolute value. So for this one, I have 2x, the absolute value of 2x plus 3 is less than or equal to 7. I always ask myself, am I going to compare this to number 1 or number 2? In this case, I'm going to compare it to number 2 because it is less than or equal to. Therefore, I need to write a compound inequality. So I need to put a negative out in front and then just write it as a compound inequality. Negative 7 less than or equal to 2x plus 3 less than or equal to 7. And we solve these just like we would any other equation. We ignore what's going on over here first. Okay, just kind of ignore that for the time being. And if I have 2x plus 3 is less than or equal to 7, to solve that, I would just subtract 3 from both sides, so I get 2x is less than or equal to 4. But in math, we are very, very, very much balanced and equal. So since I subtracted 3 from the right side of the inequality, I must also subtract 3 from the left side of the inequality, so I get negative 7 minus 3 is negative 10. Now I have negative 10 less than or equal to 2x less than or equal to 4. In order to get x alone, I have to divide by 2. So I divide everything by 2 because we are fair in math. When I divide everything by 2, I get negative 5 less than or equal to x less than or equal to 2. The nice thing about a compound inequality is your solution set and your shading look very much the same. I have everything in between in my inequality, and then I shade in between. For number 6, the first thing I have to do is get the absolute value alone. So notice I added 2 to both sides here. And then I have the absolute value of 3 plus y is greater than 2. So I solve it like it is. 3 plus y is greater than 2. Subtract 3 from both sides, so y is greater than negative 1. Or, because it's a greater than sign, I need to do 3 plus y is less than negative 2. So I switch and I negate it there. So then I solve it like I normally would, get y alone, subtract 3 from both sides, so y is less than negative 5. Y is greater than negative 1 goes this way, and then y is less than negative 5 goes that way. So for number 7, alright, for number 7, I just have a normal absolute value. This is less than. Alright, with this inequality, the first thing we have to do is look at it, is it like number 1 or like number 2? Because it's less than, it is like number 2, I believe. Like number 2. So we need to write it as a compound inequality. To write it as a compound inequality, we just put the negative 11 out in front, put another less than sign there, like we did here. And that will give me negative 11 is less than x over 2 minus 5 less than 11. My goal is to get x alone. In order to get x alone, first I have to add 5. So if I add 5, I need to add on both sides. So I would have negative 6 less than x over 2 less than 16. Now to get x alone, I need to multiply everything by 2. So I have negative 12 less than x less than 32. And then because it's less than and not less than or equal to. I have the open circles, and I shade in between because it's a compound inequality. Number 8 is actually a really easy problem to write as a compound inequality. You always put your smallest number on the left. Over here it is 6. And you put the largest number on the right, which is 10. You put your variable in the middle, which in this case is y. And then you either use less than signs, less than or equal to signs. Never greater than signs. It's not liking when I write less than or equal to. So it's either less than or less than or equal to. Okay, so when you do that, negative 14 is my smaller number. My larger number is 5. I put y in the middle. And since these are both less than symbols, I do less than, less than. They were less than or equal to symbols, I would have to do less than or equal to for both of them. If there was one of each, then I would make it one of each. It all depends on what's there, what I do with it. I hope this made it a little bit easier for you to read and understand, because these were long notes and there was a lot involved with this. So hopefully this will help clarify it, and it kept the video a little bit shorter than it normally would have. Remember, you have a quiz coming up in about 2 days, and that is it. Have a good night.